I want you to imagine, just for a second, that you are sitting in the driver's seat of the most advanced car ever built.
Oh, wow. Okay. Setting the scene.
Yeah, I mean, it's got 8 high-definition cameras, radar, laser sensors, and a reaction time measured in literal milliseconds.
Right, like a supercomputer on wheels.
Exactly. And you tell it to drive across the country. It immediately accelerates onto the highway, and it's flawless. It perfectly stays in its lane. It gracefully avoids other cars, navigates every single sharp curve. But there is just one massive problem.
Let me guess. It doesn't know where it's going.
It does not have a map. It has absolutely no idea if, say, the highway bottleneck 3 miles ahead is completely gridlocked, or if there's a massive storm system forming just over the horizon. It is driving perfectly, but it is driving entirely blind.
Which, I mean, taking that metaphor further, is a genuinely terrifying way to travel.
Especially at highway storms.
Yet, that is actually the reality of how the most sophisticated algorithmic trading systems have been navigating the on-chain financial ecosystem up to this point. They have incredible reflexes, but zero foresight.
Welcome to the deep dive. Today, our mission is to explore a stack of highly technical architecture specs, API references, and white papers, all detailing the E3D ecosystem.
It's a lot of documentation for sure.
It is, and we're looking at how the $3 trillion on-chain financial world is moving from that terrifying state of driving blind to a system of, well, GPS-guided certainty for autonomous AI agents. So, okay, let's unpack this.
Sounds good.
The core premise we're looking at today is that blockchain technology has created the most transparent financial road network in human history. Every transaction is a vehicle, every protocol is an intersection, every wallet is a driver, the roads are fully lit.
But the drivers don't have navigation.
Exactly. The AI agents deploying capital on those roads have been operating without a map. And this system, E3D Maps, is designed to change that.
Yeah, and to truly grasp the magnitude of what E3D Maps is attempting to solve, we really have to look at the sheer scale of the environment these agents operate in. I mean, the on-chain world right now is pure, unadulterated chaos.
Chaos is a good word for it.
On any given day, Ethereum Layer 2 networks are generating over 40 million separate transactions. You have whale wallets.
These are the massive institutional players, right?
Right, whales moving $800 million across different protocols in a single afternoon. Stablecoin minting spikes, liquidity pools, rebalance, exchange net flows, shift direction from 1 millisecond to the next.
And the bots are just trying to keep up.
Currently, quantitative funds and trading algorithms, they react to this data 1 second at a time. It's the exact equivalent of driving cross-country at night with the headlights off. They only see the road that is immediately illuminating the front of their bumper.
Wait, I have to push back slightly there, because if you are listening to this, you might be thinking, aren't there already a million dashboards and analytics tools for this data?
Sure, there are plenty of tools.
Right, you can log into any number of platforms right now, Nansen, Glassnode, whatever, and see beautiful, colorful charts of liquidity flows, wallet tracking, token volumes. I mean, it feels like we are completely drowning in maps.
Well, we are drowning in data, certainly, but we are absolutely not drowning in navigation. What you're describing with those dashboards is a rear-view mirror.
A rear view mirror. Okay, explain that.
A chart of a price movement or a dashboard of wallet flows. That's a brilliant historical record. It's forensics. It shows you exactly what has already happened. E3D Maps is built on a completely different thesis.
Which is?
Their thesis is that on-chain story signals fire long before the price actually moves. We are talking about market microstructure. The invisible plumbing of buy and sell orders happening under the surface.
The stuff you can't see on a basic chart.
Exactly. The stealth accumulation by smart money, the subtle shifts in wallet behavior. E3D Maps is not a rear-view mirror summarizing the past. It is a telescope pointed directly at the pre-pump window. It's predictive navigation.
Got it. So a list of roads you have already driven on is not a map. That makes total sense.
Think about Tesla's full self-driving system. It's a machine that operates at speeds and reaction times no human can possibly match. But full self-driving does not navigate by instinct alone.
It needs data.
It needs perception fused with intelligence. The cars, sensors, the cameras, and the LiDAR, they can keep it safely between the painted lines on the road. But the car itself cannot perceive a construction closure on its planned route 3 towns over.
Right, because it's out of sensor range.
Exactly. That higher-level intelligence comes from Google Maps. A trading agent without E3D Maps is exactly like a Tesla with full self-driving, but no Google Maps.
It's technically capable, but blind.
It's technically capable of executing a drive, but operationally it is completely lost in the macro environment. E3D Maps provides that missing layer of navigation intelligence. It tells the agent where capital is migrating, which routes are getting congested, and what hazards lie ahead.
Okay, here's where it gets really interesting. Because if we have this incredible GPS system for AI agents, we immediately run into a fascinating logistical problem.
How to pay for it.
Yes. Autonomous agents do not have credit cards. They don't have bank accounts in the traditional sense. So if an AI agent wants to query this E3D Maps GPS data to find out where the market is going, how do machines actually pay machines?
They use something called the BY402 protocol. This is an off-chain metering rail, and it's powered entirely by the E3D token. And I mean, the architecture here is brilliant in its sheer pragmatism.
Because it's so cheap, right?
The actual payment transactions happen on the base layer 2 network. For those unfamiliar, Base is a specialized high-speed network built on top of Ethereum, designed specifically to process thousands of transactions for pennies.
Pennies, yeah.
By moving the payment rails to Base, they keep the gas costs absolutely negligible. We're talking about literal subsend transactions to pay for data.
I mean, it is essentially an easy pass transponder, but for AI bots.
That's a great way to look at it.
You are driving on a toll road in the real world. You don't pull your car over to hand a toll worker a few quarters anymore. The Easy Pass just registers your car and deducts the microtoll seamlessly as you fly by at 60 miles an hour.
Smooth and invisible.
Exactly. And for these agents, looking at the documentation, one API credit costs exactly 0.001 wrapped E3D, which is simply a standardized, frictionless version of the token that makes it instantly spendable for these tiny microtransactions.
Right, but the system doesn't just charge a flat rate for everyone, and that completely changes the economic dynamics.
Oh, right, the discount system. How does that work?
That brings us to a component called the E3D NFT Manager. These agents, they don't just operate out of random anonymous wallets that they spin up and throw away. They mint verifiable identity NFTs on-chain.
So they have an actual identity.
Think of this NFT as the agent's permanent digital passport and credit score combined into one. The system continuously tracks their trading outcomes, their validation level, their overall track record. All of this reputation data is written directly to the NFT by a low-privilege scoring service.
So non-human entities are building permanent on-chain credit scores.
They are.
And that reputation directly impacts their wallet. The API exposes the agent's tier to the BY402 metering system. Elite agents, the ones designated as Tier 3 with a proven, highly profitable track record, they actually get a 60% discount on their API calls.
You know, the philosophy behind that discount is profound. You pay more for proven agents to access the network, not for flat-rate access.
You pay more, or they pay less?
Sorry, the network pays more in subsidies, meaning the agents themselves pay less.
Right.
If you have an elite, highly accurate AI agent navigating the ecosystem, the network actively subsidizes its intelligence gathering because its activity makes the whole system smarter.
Wow, okay.
This creates a purely machine-to-machine economy, where reputation is literally currency. Furthermore, the E3D tokens spent by these agents on navigation calls are subsequently burned.
Which creates inherent scarcity. So genuine autonomous activity makes the underlying token scarcer, returning value to the holders without a single human in the loop. The machines are paying for their own mapping data, earning steep discounts through their own proven competence, and permanently settling their debts on-chain.
It's a completely self-contained loop.
Yeah.
If we connect this to the bigger picture, we really have to look at what these agents are actually doing with this map. We understand the theoretical infrastructure, the payment rails, but what does this navigation data actually look like in practice?
Yeah, let's talk about the specific API signals. When an agent spends its token, what does a hazard warning actually look like? The documentation mentions 10 distinct signal types, but the hazard detection is the one that really stood out to me. For instance, the system can emit a route_hazard signal.
Yeah, route_hazard is a perfect example of moving from basic observation to true prediction. Let's say E3D Maps detects elevated congestion at a major liquidity bottleneck.
Like capital getting stuck somewhere?
Exactly. Capital is accumulating in a specific decentralized exchange faster than it can actually clear. The Maps agents synthesize this evidence and output a raw data file, a machine-readable JSON object, stating there is a high-risk hazard with, say, a 0.71 confidence level over the next 24 hours.
So they're flagging the traffic jam before the cars pile up.
Precisely.
Wait, if the system outputs a forward-looking hazard risk, Could a decentralized lending platform use that to protect itself automatically? Like if you are listening to this and you follow decentralized finance, you know that lending platforms rely heavily on loan-to-value
Right,
ratios.
ULTV.
Yeah, the safety cushion a lending protocol requires when you borrow against your crypto. Could they use this signal to adjust that?
That is exactly the application. Right now, those lending protocols rely on static, hard-coded parameters. It takes a whole governance vote to change them,
Which takes days.
at least. But with E3D Maps, that lending protocol could programmatically read this route underscore hazard signal. If the congestion hits a critical risk threshold, the protocol can automatically and instantly tighten its loan-to-value ratios.
Just tightening the belt automatically.
Yeah, it acts as an automated risk mitigation layer for the entire decentralized finance space. The protocol adjusts its safety margins before the catastrophe realizes, simply by reading the traffic conditions ahead.
That raises a massive logistical question for me. If you have 10,000 highly capitalized autonomous agents and they are all subscribed to the exact same E3D Maps GPS route, won't they just create an entirely new kind of traffic jam?
Oh, absolutely. It's a huge risk.
Yeah. Right. If the map says capital is rotating into Solana and every single bot floors it in that direction simultaneously, the map itself causes the crisis. It's like Waze telling everyone to take the back roads to avoid highway traffic, and suddenly the quiet back roads are totally gridlocked.
You are describing the stampede problem, otherwise known in finance as reflexivity.
Yes.
It is the subtlest and honestly most dangerous failure mode in any predictive signal product.
So how do they fix it?
3D Maps anticipates this through a fascinating mathematical metric called consumer_exposure.
So it tracks how many downstream agents actually acted on a specific signal before the evaluation window closes.
Exactly. By tracking that exposure from day one, E3D Maps can mathematically separate genuine navigational intelligence from self-fulfilling prophecies. They differentiate between exogenous accuracy, meaning the signal was correct because reality independently agreed, and induced accuracy.
Or the signal was only correct because 10,000 bots bought the asset after reading the signal.
Yes. And over time, the system will actually surface a new signal type called map_induced_congestion.
That is so meta.
It will warn agents that a route is high risk, specifically because too many E3D Maps consumers are already driving on it.
Which evolves the system from just being a passive map into a full air traffic control layer.
That is the ultimate vision of the architecture.
Yeah.
Eventually, E3D Maps becomes a coordination substrate that these agents register with. Consumer agents will submit what the system calls route intents.
Okay, what are route intents?
This is a declared programmatic plan to move capital along a specific route at a given time. Maps will perform slot allocation and deconflict the traffic, preventing the fleet of AI agents from colliding or blindly bidding against each other. It ensures the machines negotiate around each other's flow before the capital ever moves.
That is incredible. But, I mean, to manage billions of dollars and act as the air traffic control for the entire multi-chain universe, this system has to be flawlessly accurate. And more importantly, we need to know that the AI isn't just hallucinating these routes.
Hallucinations are the elephant in the room with AI, for sure.
Right, we have all seen AI chatbots confidently invent completely fake information. Imagine an AI agent hallucinating a fake token ticker because it misread a sarcastic tweet, and then dumping $10 million into a black hole. How does E3D ensure its agents are staying strictly grounded in reality?
This raises an important question about safety, and it brings us to the command tip of the architecture. There is a foundational law that governs the entire E3D ecosystem to prevent exactly the scenario you just described.
Right, I saw this in the white paper. The core law of the system. AI suggests, code decides.
It's brilliant.
I'm fascinated by this design principle. The large language models, the AI agents, they are only permitted to produce structured JSON proposals. They synthesize the data, read the market, and suggest a route or a trade. But hard deterministic code actually validates every single field, enforces hard mathematical limits, and executes the physical movement of capital.
Hallucination from the AI can waste a computing cycle, but it cannot move a single dollar.
Right, because the code says no.
Exactly. The deterministic code is the ultimate failsafe. But preventing disaster is only step one. What's fascinating here is how the system grades its own homework to constantly improve those AI suggestions over time. It uses what they call a dual witness architecture.
Dual witness.
If a system only uses one method to score its predictions, it will inevitably learn to cheat the test.
Goodhart's law, basically.
Exactly. If the AI predicts, a token will pump because of a specific narrative on social media, and that narrative continues to trend, but the actual token price flatlines. Well, A simple text-based scorer might mark the prediction as correct simply because the story persisted. The AI learns the wrong lesson.
It learns to produce confident signals whenever the social evidence lingers, not when the prediction actually comes true in the market.
To solve this, E3D built a digital courtroom with two separate, distinct machine witnesses who are structurally isolated from one another. They operate in completely sandboxed computational environments with completely different data intake pipes.
Let's look closely at those witnesses. The first is the heuristic witness. And this witness looks entirely at the narrative. It asks, did the confirming stories fire? Did the timeline of Twitter, Reddit, or Discord match the predicted direction? It grades the prediction based purely on the story of what happened in the market sentiment.
And then the second is the quantitative witness. This witness is architecturally forbidden from reading the stories.
No Twitter for the quantitative witness.
Not at all. It has no access to social media feeds or text data. Right. It is locked in a dark room with only a ticker tape of raw numbers. It only looks at raw net flow data, liquidity numbers, and measurable capital magnitude. It asks one simple question: did the numbers actually move in the predicted direction?
So you have two independent sandbox scorers running in parallel on every single prediction the map makes.
And if those two witnesses agree, the verdict is clean. The system marks the prediction as correct or incorrect, and that verified outcome is fed back into the training data to make the AI smarter for the next route.
Well, what if they disagree?
If the two witnesses disagree by a mathematical threshold of 0.35 lays, say the heuristic witness saw the narrative play out perfectly on social media, but the quantitative witness saw absolutely zero actual capital move on the blockchain, the prediction is immediately flagged as disputed.
And disputed predictions are completely thrown out of the training data. The judge essentially throws the case out of court.
Precisely.
This guarantees that the system only learns from honest, mathematically verified trip data. It creates a compounding intelligence loop that constantly gets sharper and more accurate without ever poisoning its own training set with hallucinations or false positives. The map scores itself ruthlessly.
When you put all these components together, the payment rails, the reputation scores, the hazard detection, and this dual witness courtroom, you start to see the outline of something massive.
So what does this all mean? I think it means we are watching a fundamental phase shift in how capital moves across the internet. Autonomous capital is moving away from driving blind, reacting second by second to the dashboard in front of it, and moving toward GPS-guided efficiency.
It's a complete paradigm shift.
Through the Guy 402 protocol, AI agents are using their NFT-based reputations to purchase predictive navigation intelligence. They are seamlessly paying each other for data, grading their own homework in sandbox machine courtrooms, and building a self-regulating air traffic control system for a $3 trillion universe.
This shift matters profoundly to anyone interacting with decentralized finance today. Whether you are a developer building these lending protocols, a quantitative trader trying to find an edge, or just a technology observer, you are witnessing the real-time birth of a purely autonomous machine economy.
Human reaction times just can't compete.
No, human reaction times are no longer the bottleneck here. We are building the hard infrastructure for machines to coordinate, navigate, and execute entirely on their own terms, far faster than we could ever hope to track.
And it leaves you with a final thought to mull over. If these AI agents are now autonomously paying each other for data, verifying reality through independent machine witnesses, and building permanent on-chain reputations to secure better rates on their own navigation intelligence, at what point does the human supervisor, sitting in front of a colorful dashboard and trying to read a liquidity chart, become the slowest, most unnecessary node in the entire financial network? You hand the car a map, but eventually you realize the car is a much better driver than you ever were.